Let's welcome to the stage Yash Bhandakkar.
Imagine your doctor saying that the operation was successful, but there is only 50% chance that you can live independently again. Yeah, that is the case with acute ischemic stroke, where a blood clot size of a pea gets stuck inside your artery, restricting the flow of blood and oxygen and killing millions of cells every minute. Stroke is the second leading cause of death globally and one of the major reasons for long-term disability. Now, how do we treat it? The answer is mechanical thrombectomy, where a thread-like device is inserted inside your artery to pull out the clot. Now, there are two main ways of mechanical thrombectomy. One is stent retrieval, where it physically binds with the clot and pulls it out. And second is aspiration, which sucks out the clot. Now, with different clots, there are different risks associated. For example, if a clot is soft and very fragile, it can break when we are trying to remove it. And that fragment can move ahead and stuck into a smaller artery. That would be more difficult to remove. So, with different clots, we have different behavior. And when I say hard and soft clot, they are the mechanical properties. And how do we know the mechanical property of anything? We try to pull it. If it breaks, it's soft. And that's exactly what I will be doing in my PhD. We'll create some blood clots of different composition, and we'll test them mechanically. We'll do different experiments, like pushing it, pulling it, twisting it. The same kind of force that the clot will experience during the mechanical thrombectomy. Now, what will I do with all this data? I need to know how the clot will behave. So since I am from maths background, I need some mathematical expression, some governing equation which will tell me the behavior of the clot. So how to get those equations, those governing equation? That's how I get the equation. Scary, right? Don't worry, I'll not talk about this. I know 90% of you don't even understand what's on that page. Neither do I. Those are Einstein's handwriting. But traditionally, if you want to get to those equations, you start with the fundamentals, first principle. You take your pen, paper, and years of theory to write down and get to those governing equations. But I will do something else. I will use machine learning. All the data which are generated using the mechanical test, I will feed that data to the machine learning algorithm to get the governing equation. The governing equation which will tell me the behavior of the clot. Now, why do I need this? Because once I know the accurate behavior of clot using my equations, I can develop better devices, design better devices, and those devices will help us for better outcomes and save lives. Thank you.